Hello, welcome. We are going to learn about 8085 microprocessor, and you're just going to do an introduction by asking ourselves questions and just going through an overview of the microprocessors. Now, are microprocessors used in the world? Yes, we can give examples of our laptops, our phones, remote controls, all that have microprocessors. Are microprocessors found in every device? No. Reason being, we cannot find a microprocessor where there is no program involved. For example, in a tube light or a fan. If we take for a tube light, for instance, it's just a matter of switching on and off, so there is no microprocessor involved. We take this definition for a microprocessor, a multipurpose programmable clock-driven register-based electronic device that reads binary instructions from a storage device called memory, accepts binary data as inputs, processes data according to those instructions, and provides results as outputs.
Let's have a look at the evolution of microprocessors. And prior to 8085, Intel had invented 4004 in 1971. It's a 4-bit microprocessor and its memory is 1 kilobyte, 16 pins, clock signal of 70 Hz. And also 8008 was introduced in 1972. It's an 8-bit microprocessor and it has 40 pins. Then we have the 8085 in 1976. It's 8-bit microprocessor. This is what you're going to learn. 64 kilobytes memory addressing capability. Consists of 40 pins, 3 to 6 megahertz clock signal. Then 8086 was introduced in 1978. It's a 16-bit microprocessor having addressing capability of 1 megabyte. Consists of 40 pins with 5 to 10 megahertz clock signal. Then we also have 8088, which was introduced in 1980. It's 8/16-bit microprocessor with memory addressing capability of 1 megabyte, consists of 5 to 8 megahertz clock signal. And the latest ones by Intel are the Core i3, Core i5, and Core i7. We go to a microcomputer system, and a simple microcomputer system contains inputs, microprocessor, which we are calling the CPU, central processing unit, outputs, and memory. And you realize the inputs, the outputs, and memory do not control each other, and all the processing is done by the CPU, which we are having here as our processor. So the inputs are devices such as keyboard and transfer binary information from outside world to the microprocessor. The output devices, on the other hand, transfer data from the microprocessor to the other world. And an example is a monitor and even a printer.
Now, going to the memory. Memory stores binary information such as programs, data, and provides that information to the microprocessor whenever necessary. So what I'm calling here MUP is what you are calling the microprocessor. So once again, there is no processing that's done by the memory. It basically stores. Its work is to store binary information such as programs and data. When we talk of programs, we are referring to things like WhatsApp in your phone, and data refers to your images and songs. Then we have the primary memory. It's a type of memory which is also called internal memory, and therefore data is easily accessed to the accessed by the microprocessor. Examples are the read-only memory and random access memory. Now we have the secondary memory, which is also known as backup memory and auxiliary memory. Data cannot be accessed directly by the processor. Examples are hard drives, flash disk. You can name all of them. Now, we go to the read-only memory. Read-only memory used to store programs that do not need alterations and can only be read. So ROM, what you normally call as ROM, content is permanent and it's non-volatile. So when power is lost, the content still remains. Then we have the random access memory, which stores user programs and data. The information stored in this memory can be easily read and altered. That's what you're calling RAM, which is volatile and it allows us to read and write. Now, in this 8085, when it was invented in 1970s, same to 8086, the secondary memory had not been invented. So whenever we shall be talking about memory in this 8085, we shall always be referring to the primary memory. And primary memory in that sense, it shall be the random access memory. Reason being, we shall be learning on how microprocessor is able to read and write from the memory. So we shall mainly be discussing about RAM. Under RAM, we have the SRAM, which uses flip-flops to store each bit. That's whenever it's set, it stores one bit. When it's reset, it stores another bit. Then we have the DRAM, which stores each bit of data in memory using capacitors. That's when it's charging, it's storing one bit. When it's discharging, it's storing another bit. Now, you find that the SRAM is fast but expensive, given that it's using flip-flops, while DRAM is less expensive, yes, but slower due to the charging time and discharging time. Now, static RAM is used to create the CPU speed sensitive parts, while the dynamic RAM forms the larger system of RAM space. So there is a good balance of the DRAM and the SRAM. The microprocessor has a very narrow view of life. It only understands binary numbers. A binary digit is a bit which comes from a binary digit. So in order to understand how memory works, you only have to understand how memory will store a 0 and a 1. Every data and program is stored in form of zeros and ones. So if you save a song in your phone, it's not saved as a song, it's saved as a series of zeros and ones. Thank you. Hoping to learn more. That was just an introduction.